Hello everyone, my name is Ariq Rahardjo, and I'm one of author for paper titled Numerical Simulation of Long Duration Sloshing using Smooth Particle Hydrodynamics for the 6th International Conference on Industrial Mechanical, Electrical, and Chemical Engineering. So let's just get started. So in this study, is carried out long duration sloshing using single-phase and two-phase SPH in the prismatic tank. Sloshing is a phenomenon of the natural event in a liquid carrier vehicle, such as airplanes, trucks, and ships. Sloshing can be defined as the resonance of fluid inside the tank caused by external oscillation. SPH, or smooth particle hydrodynamics, is massless CFD and a Lagrangian scheme. In this study, the dynamic pressure of SPH was validated using the experiment result. The same duration sloshing was made with an experiment in SPH simulation. In the study, open source SPH software called DualPhysics 4.2 version is used to carry out the sloshing simulation. All simulations in the study were executed using GPU GTX 1080 Ti to accelerate the computation time. For the method section is discussed about the simulation and experiment condition. First is the 3 pressure sensors were used in the experiment because only 25% filling ratio is used. Only pressure sensor located in bottom was used in this study. Pressure sensor is close to free surface in 25% filling ratio. The movement of tank in the SPH used directly from the experiment. The long duration time sloshing is used 70 seconds. There is addition time to second to settle down the fluid particle and to get hydrostatic pressure. The comparison was made with analytic solution for the hydrostatic pressure. The dynamic pressure was compared with experiment result. So this is the displacement graphic of sloshing tank in the experiment, and in the right side is the figure of prismatic tank with 25% filling ratio. So the result and discussion. One-line kernel function is used in the SPH simulation. The initial particle distance is 0.8 mm with total particles 90,000 for two-phase and 23,000 for the single-phase. The speed of sound for water and air is 65 meters per second and 343 meters per second. The speed of sound and initial particle distance have a significant effect to pressure prediction. Because by default DualPhysics is based on weakly compressible SPH, as a result the pressure has a significant noise. The pressure is SPH will have a spurious pressure oscillation caused by density fluctuation, especially for weakly compressible SPH. The filtering technique is needed to reduce or remove the noise using a low-pass filter. The hydrostatic pressure has a good agreement with analytic solution, where is the difference below 2%, both for single and two-phase SPH. The dynamic pressure shows similar result with the experiment, but accuracy is slightly less accurate compared with hydrostatic result. It can be seen that dynamic pressure in each simulation has significant noise compared with other parts for single-phase SPH. Two-phase SPH show could reproduce better than single-phase SPH. It could be because by air phase in two-phase SPH that affected that fluid compressibility. Two-phase SPH show could capture phenomena of the tail pressure after the peak pressure. In contrary, single-phase SPH could not capture this event. It can be seen two-phase SPH matched with experiment. Single-phase SPH depicts that fluid particle easily detaches and less run up during impact with the side wall of the tank. So this is the visual comparison of single and two-phase SPH. Next is the comparison of static pressure in single phase and two phase. So this is the comparison of dynamic pressure for single phase SPH. And this is the comparison of dynamic pressure for two phase SPH. And this is the snapshot of experiment single phase and two phase SPH. So the conclusion, it is found that SPH can reproduce hydrostatic pressure and dynamic pressure using single and two phase SPH. Spurious pressure oscillation exists. 2. The tendency of pressure is similar to the experiment. Air phase in sloshing simulations show essential to match free surface evolution with experiment. So that's all, and thank you.